All right, so are there any of the problems on the homework about which you have questions? Yes, ma'am. Number 4, okay. So find the general solution, write your answers in explicit form if possible. When it says explicit form, that means, y equals something. Just making sure that that was clear. All right, so for number 4, let's carve us out some room here. Ooh, didn't realize I was in red. So what color and what color should I write in if this is red?
You can make a custom color and choose
I don't want to make a custom color. Yama, what do you think? What color should I write in?
Purple?
Purple?
Yeah, there's
There, what? Here?
the purple one.
That one?
Yes.
Okay.
Wow, I forgot.
Oh gosh, this may kill me. All right. So when you separated the variables, you should have 1 over e to the y. Let's make that a little. Let's do
I
some
think you blocked it better.
dy. Ooh, that pops.
Yeah.
I like that. Equals x dx, right? Is that what you had? So here's what you want to do. The 1 over e to the y, like, what the heck am I supposed to do with that? Well, think of it as e to the negative y. dy is equal to x dx. And then we want to take the antiderivative on each side. So if it was just e to the y, the antiderivative would be e to the y, right? So that's going to be part of it. It's going to be part of it is e to the negative y. But then you're like, well, if I take the derivative of this, I have to use the chain rule, and I'll have times negative 1. So to undo that, I'm going to put a negative here. Is equal to 1/2 x squared plus c. So was it the left side that gave you trouble? Yeah. So I'm trying to get you to think more about this idea of being able to do an antiderivative by sort of undoing the chain rule. So now I'm going to try and solve this for y. So I'll multiply both sides by negative 1. And I'll have e to the negative y is equal to negative 1/2 x squared. And yes, it should be minus c, but I'm going to just call it plus a different constant. Then if I'm trying to solve this for y, I need to take the natural log of both sides. And I'll have negative y is equal to the natural log of negative 1/2 x squared plus c. And then multiplying both sides by a negative, we'll have y is equal to negative natural log of negative 1/2 x squared plus c. And notice that on this is not a continuous function, right? So we need to think about, well, what is the domain going to be there? I need for negative 1/2 x squared plus c to be greater than 0. So that would mean that c needs to be greater than 1/2 x squared. So you can continue that. 2c needs to be greater than x squared, taking the square root of both sides. So x has to be less than the square root of 2c. Would be our domain for that one. Okay? So it's mostly just the e to the negative y, right?
Yeah.
Did you just write e to the negative y without the negative in front? Okay. All right, what other questions do you have? Number 9, okay. One with an initial condition. Oh my. Oh, let's do the opposite this time since I'm in this. What color would you call that?
Cyan. Or turquoise. Not turquoise.
It's not quite deep enough for turquoise, but it's close.
I just call it cyan.
Okay. So when you separate this, we're going to have the integral of y e to the negative y squared dy is equal to x dx. Right? So now it's like, okay, well, what am I going to do here? Again, think about undoing the chain rule here. If I know that e to the negative y squared is going to be involved in that, correct? But if I take the derivative, I'm going to come over here, the derivative with respect to x of e to the negative y squared is e to the negative y squared times, because of the chain rule, negative 2y. You're like, well, that's not quite what I have here, is it?
So we should multiply by -1/2.
Yeah. So this is going to be negative 1/2 e to the negative y squared is equal to 1/2 x squared plus c. We might as well finish it. We have lots of time today. So substituting in y is negative 1 and x is 0, we have negative 1/2 e to the negative 1 squared is equal to 1/2 of 0 squared plus c. The right side's just c. The left side is negative 1/2 e to the negative 1. Or if you prefer, negative 1 over 2e. So going back up to the level where we first substituted, I'm going to have negative 1/2 e to the negative y squared is equal to 1/2 x squared minus minus 1 over 2e. So multiplying everything by negative 2 to get rid of the negative 1/2, I'll have e to the negative y squared is equal to negative x squared minus or plus 1 over e. Then we'll take the natural log of both sides and have negative y squared is the natural log of, I kind of like writing it so that the positive one's first, so that it's just 1 over e minus x squared. It's not a big deal, but you'll find a lot of times if this is a multiple choice question that they'll do that. It cleans it up, ever so slightly. That's not a requirement for something that you guys are doing on a homework assignment or anything. Multiply everything by a negative. And then take the square root, and notice that we want f of 0 to end up being negative. So I want the negative root. So y is going to be the negative square root of negative natural log of 1 over e minus x squared. And I like to, we talked about checking these by taking the derivative. There's no way I'm checking this by taking the derivative. It's just too ugly. But I will make sure that f of 0 comes out to be negative 1, because that doesn't take very long. If I substitute in 0 here, I've got natural log of 1 over e, which is negative 1, times the negative is positive 1. Take the square root, still 1, multiply by negative, negative 1. Huzzah! The last thing on that is you really should think about, again, this is only this, to take the square root, I need for negative natural log of 1 over e minus x squared to be greater than 0, which means the natural log of 1 over e minus x squared needs to be less than 0. Using both of those sides as an exponent on e, I get 1 over e minus x squared has got to be less than e to the 0 is 1. Good. So now I've got, if I subtract 1 over e from both sides, I have negative x squared is less than 1 minus 1 over e. Multiply through by a negative again. This is kind of ugly. X squared's got to be greater than 1 over e minus 1. So x has to be, and this is where it gets kind of hinky again. You're like, okay, well, it could be that x is greater than the square root of 1 over e minus 1. But it could also be less than the negative square root. I think that's how that works.
So, can you remind me as to why we have to write the domain?
I suppose if a problem doesn't explicitly ask you for it, it's not always a big deal. But part of what I'm trying to point out to you here is, like on slope fields, or anytime you're solving a differential equation, when there are multiple branches, our solution, if we have an initial condition, is only one of those branches. So
I remember now.
So we're specifying, well, which of the branches is this? All right, what other questions do you have? Number 5, yes, ma'am. All right, so when we separate this, we're going to have 1 over y dy is equal to x over the square root of 1 minus x squared dx.
I see what I did wrong.
What happened?
I didn't recognize. Wait, is x over 1 minus square root of x?
It's not any of the inverse trig functions.
Right.
If it didn't have an x on top,
It would be arc sine.
it would be arc sine, yes. So the left side, you're probably pretty happy leaving it as 1 over y, because you know the antiderivative of that is going to be natural log of the absolute value of y. Over here, what I would say is, think of it this way. 1 minus x squared to the negative 1/2 times x dx.
Okay, yeah. I see now.
So again, we can be thinking about that undoing the chain rule idea. And you're like, okay, so if I'm just thinking about this, I'm like, okay, well, I think part of it is going to be 2 times 1 minus x squared to the positive 1/2. So that when I take the derivative of that, I'm going to get this part. But then the chain rule part is going to give me a negative 2x, right? So I need to multiply by negative 1/2.
But can you just not write the 2 and just write negative?
In the end, yes. But I didn't want to just jump straight to that. So then, as Irfan points out, these 2's cancel each other out. So then the absolute value of y is going to be equal to c e to the negative 1 minus x squared to the 1/2 power. Because it's that whole e to the something plus c is c times e to that something. Yes, sir.
Can you do 8?
Yeah. Hang on just a second. Okay. So y tangent of x. So when you separate it, you have dy over y is equal to tangent of x dx. So far, so good. And it's that right side that it's like, how do I take the antiderivative of that? All right, so here, natural log absolute value of y, not a problem. The right side's a little more difficult. Okay, and again, this is something where you can kind of reason your way through it, undoing the chain rule, but you're like, well, how am I going to undo the chain rule? There's nothing to undo. We'll actually do this one a little later. Again, I'm previewing a bunch of stuff in this unit, but I'm going to rewrite this as sine of x over cosine of x. And you may remember Wednesday, we talked about when you have a function in the denominator and its derivative in the numerator, that's going to be, when you take the antiderivative, a natural log. Well, that's what's going to happen here. I've got cosine in the denominator, and, well, very nearly its derivative. The derivative of cosine is negative sine, so I'm going to go, okay, I'd like that to be negative sine. So I'll just stick a negative there and there. I haven't changed its value. So I have a function in the denominator and its derivative in the numerator. That's natural log. So this is going to be natural log of the absolute value of y is equal to the opposite of the natural log of the absolute value of cosine plus c. So then the absolute value of y is going to be equal to c e to the negative natural log of the absolute value of cosine of x
There's something going
Pardon?
Is something going on?
No, just it's always interesting to watch, people come in and people go out and parents dropping students off at all kinds of interesting times and reading the body language. Is the parent mad at the kid because the kid, made themselves late?
Or is the parent? Because sometimes the parents make the
Right. Sometimes it's the parent's fault, trying to read all that without hearing anything. I like to people watch. All right. Are there any others you would like to see worked out?
Yeah, on 8, it says the answer is simplified even more. On 8.
On 8?
Yeah, the answer they said was y is equal to c times secant of x.
Oh, okay. So, yes, we can continue that. I didn't think about it, but yes. Because I have an e to the natural log, I need to get rid of the thing in between them. So I can say the absolute value of y is equal to c e to the natural log of the absolute value of cosine of x raised to the negative 1 power. Cosine to the negative 1 power is secant, and e to the natural log of secant will just be secant. Oops. So it's just c times secant of x. Yeah, I should have thought of that. Anytime you've got e to something that's natural log, if you can get rid of the coefficient, move that back. You can simplify it.
Can you do? Yeah, I got that.
You good from there?
Can you do number
13? Yes, ma'am. This one looks a little more straightforward than some of the other ones, but we shall see. So we're going to have, after you separate and put an integral sign, 1 over y dy is equal to the integral of e to the negative x dx. Oh, is it that same problem you had earlier with the e to the negative y? Yeah. This is going to be the natural log of the absolute value of y. And this is going to be negative e to the negative x plus c. And as with all ones where I have a natural log, I don't go ahead and solve it. I think it's easier to wait. I can drop the absolute value on the y because my y value is indeed positive. So I'm going to have y is equal to c e to the negative e to the negative x. Wait a minute. Yes.
Why?
Because I'm raising both sides to, I'm using both of them as a power on e. So now substituting in x is 0 and y is 1, I have 1 is equal to c e to the negative e to the 0 power. So that's 1 is equal to c e to the negative 1. Multiplying both sides by e, I get e is equal to c. So then going back up to here, I've got y is equal to e times e to the negative x, which is kind of funky looking. Remember that this is to the first power, and when you're multiplying those two, we can simply add the exponents. So we could rewrite that as y is equal to e to the 1 minus e to the negative x. And it looks a little less janky.
do number 15?
Sure. All right, so number 15, when we separate this, we're going to have 1 over y squared plus 1 dy is equal to 1 over the square root of 1 minus x squared dx. So far, so good? All right, and we're going to take the antiderivative of both sides. This is a simple, do you recognize these? So remember that the derivative with respect to x of the arctangent of x is 1 over 1 plus x squared. So this is the arctangent of y. And on the right side, do you recognize that one? Arcsine. Yeah. So this one is arcsine of x plus a constant. So substituting in 0, 0 to find c, I've got the arctangent of 0 is equal to the arcsine of 0 plus c. Tangent is 0 at 0, so that's 0. Where is sine 0? At 0. So c turns out to be 0, which is kind of nice. So then I just have that the arctangent of y is equal to the arcsine of x. Take the tangent of both sides, and I have y is equal to the tangent of the arcsine of x. Okay? Anything else? Or find you good? Okay. So yeah, that assignment was kind of a let's stretch everybody some. Okay. Well, I have a worksheet for